So Y bus formation by using singular transformation method. So already we have derived one more method, Y bus formation by using direct inspection method. So that method is used when the number of buses or number of nodes in the network are very less. That means like less number of nodes are there, then we can easily write the equations, we can write the matrix of Y bus directly by seeing the network. But if number of nodes are more, then definitely more number of equations will be involving. So that becomes very difficult to write the Y bus matrix. So then we need to go for another method which is called Y bus forming by using singular transformation method. Y bus forming by using singular transformation method. The main point you need to remember in this method is this method mainly uses bus incidence matrix. That means how many number of elements incidented to particular bus. This matrix we have already derived. How to write the matrix we have already done. We will, while solving the problems also, again we will discuss about this. So this matrix, this method definitely uses bus incidence matrix A, capital A. So according to this method, the final equation is Y bus is equal to A transpose into Y into A. So A transpose is nothing but transpose of bus incidence matrix. A is already, you know, a bus incidence matrix. So this Y already I have given example yesterday. This Y is nothing but self-diagonal elements. It is what we call, it is a matrix related to what we call driving point impedances. That means only diagonal elements will be there. That means I can have given some what we call example also yesterday. Y11 0 0 0 Y22 for example, if it is a 3 by 3 matrix, I am writing like this. And this is 0 0 Y33. So this is the network. So these values will be given for the network while solving the problems. They will give. So this is Y. Whatever the Y here, whatever the Y we are using, this is what your Y. So, but if any mutual impedances, for example, if the bus number 1 is there, bus number 2, bus number 3 is there. So there is one connection to bus number 1 to 2, and here the one more connection like this. If it is like this. So if there is, for example, this is element number 1, this is element number 2. If there is incidence between, if there is a mutual impedance between these two elements, 1 and 2, if there is a mutual impedance between these two elements, so then there exists an element of small y12. That means we can have element here y12 and we can have element y21. That in the problem, if they specify that if there exists any mutual impedance, then definitely these elements will not be zero now. This is not zero. This is not zero. Now we can replace this given value, whatever in the question they will give, that value will replace here. So while solving, I'll explain this, no problem. So this method uses bus incidence matrix. So in the very first step, we know, yesterday we have discussed it. A primitive network is nothing but an unconnected element that can be represented either maybe in impedance form as well as admittance form. So now I am representing a network element, a primitive network in admittance form. That means two nodes are there. One is P, one is Q, and element admittance is given by YPQ. The current flowing through the element is IPQ, and a active current source is there in the element. The current delivered by the active source is nothing but the JPQ. Now at this node, if we want to write the current equation, that is IPQ plus JPQ is equal to YPQ into what we call V. We have written what the voltage across this element, that we have written Y into V. So based from that only we have written this performance equation yesterday. Already we have done this. I plus J is equal to Y into V. So what is this? I plus J is equal to Y into V. This equation we know. Till this point we know. Now in the very first step to derive the Y bus matrix, in the very first step what we will do, we will pre-multiply. That means multiplying both sides. This equation, you treat this as equation number 1. This is equation number 1. So multiplying this complete equation number 1 both sides with A transpose. So that means this equation should be multiplied both sides with A transpose. A transpose into here also into A transpose. Like this we will multiply here. So that step was done here. So A transpose into I plus A transpose into J is equal to this side also A transpose into Y into V. This V we are representing with capital small v. Why? Because this is this is primitive network, no? This is voltage for one element only. We will represent capital V for what we call for complete power system network. For if you have 4 buses like this, then the voltage at all the buses can be represented with, or the voltage related to 2 or more buses. If you want to write it, we can represent with the capital letters. But this is a primitive network, no? This is an unconnected element. So that's why we are representing with small v. That too, it's a vector, it's a column vector. That's why I am representing with the. I explained. I yesterday also have explained. What about this current? I is also a column vector. I know we know that yesterday I have explained. No, what is the order of I here? Can anybody say? Yesterday I have told you. Yesterday I have explained many times. What is the order of I? I is a column matrix. What is the order?
N by 1.
N by 1, very good. N by 1 is not, N is nothing but the number of, what we call, number of elements. N is nothing but the number of elements. So N is nothing but the number of elements, or number of transmission lines, or number of what we call unconnected elements. So N is number of elements. So I is a column matrix, J is also column matrix, this small v is also column matrix. So now the question mark is, sir, why we need to multiply with A transpose? Why not we multiply with A? Actually, what is the necessity to multiply with some A or A transpose? So that I want to explain to you. See, this explanation is not given anywhere. Please try to understand why we are multiplying. You can directly write multiply with A transpose on both sides. But what is the reason to multiply A transpose with both what we call in the both sides of this equation? Let me explain this, okay? So, for example, if it is a 3 by 3 matrix, what we call, if it is a 3 bus system, for example, if it is a 3 bus system, then what is the I matrix? What is I here? If it is a 3 by 3 system, what is the order? What is the order of I matrix? If it is a 3, if it is a 3 bus system, for example, if the network is a 3 bus system, and the number of elements are, for example, 5, or otherwise I am saying, I am writing here, if number of elements are, I am writing here, if number of elements are, E is nothing but number of elements, if number of elements are 5 and number of nodes, that means number of nodes present is 3. Now tell me, what is the matrix, what is the order of matrix I? If number of elements are 5 elements and number of nodes are 3 in any given power system network, so this I is there. Now what is the matrix order? Now can anybody please tell me? Here
5 by 1.
5 by 1, very good. This is 5 by 1 because, for example, if the network consisting of 5 transmission lines, everybody try to concentrate. If a network consisting of like 5 transmission lines, how many currents will exist? If network consisting of 5 transmission lines, how many currents will exist?
5.
5 only, no, because each and every transmission line carries some current. For example, transmission line 1 will carry current I1, line 2 will carry I2, line 3 will carry I3, line 4 will carry I4, line 5 will carry I5. Now, what is the order of this matrix? 5 into 1 only, no, because 5 rows, 1, 2, 3, 4 and 5 rows, but only one column. So that's why we have written 5 into 1. But if we take the network, 3 nodes I am saying, no, here number of nodes are 3. For example, if the network consisting of 3 nodes, then what is the A matrix? Please tell me, what is the A matrix? What is the A matrix? Element to node incidence matrix, no, sorry, bus incidence matrix, no. So what is the order of a matrix A now? Can anybody tell me what is the order of matrix A?
5 into 5.
See, this matrix we will write with respect to elements to the buses, number of elements on the vertical, number of buses on the horizontal. For example, if number of buses 3, assume that number of buses is 3. That is 1, that is 2, that is 3. So now what is the, how many elements are there here? 5 elements. So 1, 2, 3, 4 and 5. Now what is the order of this matrix? Can anybody?
5 cross 3.
5 cross 3. Very good. 5 cross 3. Now can we multiply A into I? Is it possible? Please check. A into
No, sir.
I. Can we multiply A into I? What is the
No, sir.
order of matrix A? It is 5 cross 3. What is the order of matrix I? It is 5 cross 1. Is matrix multiplication is possible here?
No, sir.
Because here dimensions are different, no? Is matrix multiplication is possible? Everybody, please tell me.
No,
I
sir.
am explaining about this expression. Why we are multiplying with A transpose? Why not A? For example, if we multiply with A, is this matrix multiplication is possible?
No, sir.
No. So, but if you want to multiply this, if you want to make it is possible, either we need to 3. This 3 we need to make it is 5. Then it is possible, right or not? Now it is possible or not? Or otherwise, this 5 you need to make it as 3. Whatever it may be, either this chance or maybe this chance. If it is 5 into 5, or other it is, if it is 3, 5 into 1, then that is possible. For example, forget about that. Now tell me this possibility, A transpose into I. Now tell me, is it possible now? What is A transpose? A transpose means what is the order here?
3
A
cross
transpose? 3 cross 5.
3 cross 5.
3 cross 5 is the A transpose. And what is the I? 5 cross 1. Now it is possible or not? Yes. This number should be same, no, for matrix multiplication. Yes or no? Do you know that or no?
Yes, sir.
So that's why we are not multiplying with A. Why we are multiplying with A transpose means current column, current vector is a column vector. It is a column matrix. Whereas A matrix is 5 by 3 here. Whereas this current is 5 by 1 here. So this matrix multiplication is not possible. But if it make a transpose of A, then the matrix multiplication is possible. This till this step, it is clear, everybody. Only just we have done, we have said, I have said that whatever the performance equation is there in the admittance form, I plus j is equal to y into v. For this equation, I have asked you to multiply A transpose on both sides. We have multiplied. And A transpose, we have checked A into I is possible. Why we are not multiplying with A? Why we are only multiplying with A transpose? That reason I have explained. If you multiply with A, matrix multiplication is not possible. If you multiply with A transpose, then only this term will converge. Otherwise, there is no convergence in this term. There is no matrix multiplication possible in this term. So now it is clear, A transpose into I. The equation number 2, you have to remember what is that equation? A transpose into I plus A transpose into J is equal to A transpose into Y into V. Is it clear now? This equation number 2 is clear, everybody? Please unmute and tell me,
Yes,
equation
sir.
number 2 is clear or not?
Yes,
Clear,
sir.
sir.
Yes, sir.
So now, yes, anybody doubt? Any doubt? Do you having any doubt? Shall we go for next step?
Yes, sir.
Yes, sir.
So first step is clear. First step is the performance equation. Second step is multiplying with A transpose. And now I am saying that in the step 3, I am saying that A transpose, we can replace this A transpose into I is equal to 0. Directly I am saying that A transpose into I is equal to 0. How can we write this? I will explain further. Yes. So please see here. So what is the A transpose? For example, if I am taking this network, you understood that you take a small network. We will check whether A transpose into I is 0, is equating, is getting 0 or not. We'll check here. For example, this is the network, small network we have taken, and the direction, for example, this is direction I'm giving here. This is the direction in this element. This is the direction, because to write the A matrix, we need the direction. And this is element number 1 I am saying. This is element number 2 I am saying. This is element number 3 I am saying. Okay. Now, what is the A matrix? Everybody know how to write A matrix. I am not taking any reference node. All are, I am considering that all are the buses only. Then can we can write the A matrix. I have explained how to write the A matrix. Here in this side, vertical side, what you will take? Everybody tell me what you will take in the vertical side. This side, what you will take? Yes, please tell me. In the vertical side, what you will take? Everybody writing, when you are writing A.
Elements.
Elements.
Elements. So 1, 2, and 3. Right? In the this horizontal side, what you will take?
Buses.
Buses. So bus number 1, bus number 2, bus number 3. So this matrix closed now. So now tell me, we know that the element is equal to 1 when the branch current is approaching the node, is towards the node. It is 1, it is towards the node, it is -1. If it is leaving, this is towards the node, this is towards the bus. Towards the bus, it is -1. If it is leaving the 1, if it is leaving away from the bus, if it is leaving the bus, then it is equal to 1. If it is leaving the bus, it is equal to 1. There is no incidence, that is 0. We know that, because if current is, if this is the bus, if this is the element, if current is approaching towards the bus, then we have to take it as a -1. If it is leaving the bus, then we have to take it as a +1. If there is no connectivity, we have to take it as 0. That we will write. We know that. Okay. For example, in the element number 1, what is the regarding what we call for bus 1, we need to write. For bus number 1, we will write. What about the element number 1? It is leaving or approaching the bus number 1. This is bus number 1. What is the branch current in the element 1? What is the branch current in the what we call in the element 1? It is leaving leaving from bus 1 or towards the bus 1.
Leaving.
Leaving means we have to take +1 or -1.
+1.
So it is 1. If element 2 is connected to bus number 1, please check here.
No,
Is
sir.
element 2 is connected to bus number 1? Connected or not connected?
Not connected, sir.
Not
So
connected.
this is 0. What about 3? It is leaving or approaching?
Leaving.
So this is also 1. What about for element? What about for bus number 2? For bus number 2, element number 1 is leaving or approaching the bus?
Leaving.
See, element number 1 this direction. This is bus number 2. Leaving or approaching?
Approaching.
Approaching. See, one current in the branch 1 is approaching. Approaching means +1 or -1?
-1.
-1. And one more element is connected to bus number 2. What is that? Element 2 is leaving or approaching?
Leaving.
So this is 1. Any element number 3 is connected to bus number 2? No connectivity. So this is 0. Coming to the bus number 3. How many connections are there? 2 connections. This is 1. This is 1. This one connection. This one connection. So is what we call any element number 1 is connected to bus number 3. Is there any connectivity here?
No, sir.
So this is 0. What about element number 2? It is approaching or leaving? It is approaching the bus number 3 or leaving the bus 3?
Approaching.
Approaching.
So this is -1. Even for 3 also, element 3 also?
Approaching.
So this is also -1. So this is about the what we call the bus incidence matrix for this network. And if you want to calculate, if this is the current I1 in the branch 1, and if this is the current I2 in the branch 2, unknown currents, we don't know. If this is the current I3 in branch 3, if you want to calculate, then here if we multiply and we'll get the three equations. What we can write here? I1, I2, and I3. So if you make a multiply, and if we may multiply and if we solve this equation, we'll get the values of I1, I2, and I3. So this is what we call how to calculate the branch currents. But when you observe the network, so if you multiply, please multiply this. What you will get the matrix? Can anybody say the equivalent matrix here? This is the 3 by 3. This is 3 by 1. What is the order of this matrix? Product matrix, output matrix now?
3 cross 1.
3 cross 1. Very good. This is 3 cross 1. Now tell me, if you multiply, see 1 into I1. Yes, we'll get I1. Minus 1 into I2. We'll get I1 minus I2. Plus 0 into I3 will get 0. Forget about this. Next, 0 into I1, 0. 1 into I2. So you'll get I2 here. Minus 1 into I3. So minus I3. This is one more equation here. And third one, 1 into I1. This is I1 here. 0 into I2 will get 0. Minus 1 into I3. Minus I3. So these are the equations when we multiply these two matrices. Is it correct or not? Everybody please unmute and tell me.
Yes, sir.
My intention is, if I want to calculate I1, I2, I3, then I will multiply these two matrices. So this is the equation. This is the final matrix 3 by 1. We will get, right or not?
Sir.
Yes. Now please tell me, forget about this. Now please tell me, if we apply KCL for each and every bus, what are the equation we'll get? For one equation number, for bus number 1, apply KCL, what is the equation we'll get? Sum of currents entering is equal to sum of current leaving. Here for bus number 1, both the currents are leaving, no? Yes or no?
Yes, sir.
So what we can write here for bus number 1?
I1 plus I3 equal to 0.
I1 I1 plus, yes, tell me. Both the currents are leaving, no? Yes.
Yes, sir.
Yes. Similarly, bus number 2.
Minus I1 plus I2 is equal to 0.
See, this is entering, this is leaving. I can write I1 is equal to I2. Entering is equal to leaving. Right or not?
Sir.
Right or not? For bus number 2, or otherwise this equation we can write I1 minus I3 is equal to 0. Right or not? I1 minus I3 is equal to 0 for bus number 2. Sorry, this is second 2, no? Equation 2. This is I2. I2. So this is one entering, this is leaving. So I1 minus I2. This is I1 minus I2. Here also this is I1 is equal to I2. So one equation we can write I1 minus I2 is equal to 0. What about at 3? What about the 3? Yes?
Minus I2 minus I3 is equal to 0.
That means in equation form what we can write? What we can write?
I2 is equal to minus I3.
Minus I3. I think there is mistake in the direction which we considered for this one. Yes, 1 is direction in this direction, 2 is in this direction, 3 is in this direction, same direction only. So we have, if we considered bus number 1, that is bus number 1, and bus number 2 bus. Okay. So now, okay, yes. So here, if you want to calculate this I1, I2, and I3, these three are unknown parameters, no branch currents. So definitely, I need to, if I want to solve these three equations, what I need to do? definitely I need to make A transpose into I is equal to 0. Right or not? If we multiply and if we make this matrix is equal to 0, then I can write the equation I1 minus I2 from this matrix I am writing. I1 minus I2 is equal to 0. This is equation number 1. And I2 minus I3 is equal to 0. This is equation number 2. And next finally I1 minus I3 is equal to 0. So my intention is, in order to calculate what we call this branch currents I1, I2 and I3, definitely this equation should be valid. A transpose into I is equal to 0. Then only it is possible to calculate I1, I2, I3 values. Right or not?
Yes,
If we
sir.
make A transpose into I is equal to 0 only, then it is possible to calculate what we call unknown branch currents I1, I2, I3. So what I am trying to say, this is the equation 2. We know that after multiplying with A transpose. Now in this step, what I have done is A transpose into I am replacing it is equal to 0. Why? Because this is nothing but this is as per what to calculate the branch currents. Always this what we call A transpose into I must be equal to 0. So substitute this equation in the equation number 2. What we will get here? If you substitute that, this is 0, no, we'll get, I am writing here, A transpose into J is equal to A transpose into Y into small v. So this is the equation we will get. This equation will take it as equation number 4. So A transpose, just remove this equation because this is 0, no. So A transpose into J is equal to A transpose into Y into V. This is V, not this is V. Okay, small v. So right. So this is the equation number 4. So I think time is over. So please remember till equation number 4. That's all. In the step 1, we have written performance equation, and then step 2 we have multiplied with A transpose, and in step 3 A transpose into I is equal to 0 to because to know to calculate the unknown branch currents.